Hello all, welcome to part 7 of the Windows Assembly Language Primer for Hackers. In this video, we will look at how to control program execution using the JMP family of instructions. So, JMP instruction we have covered in detail in the Assembly Language Primer for Hackers video series for Linux. Have a look. In this series, as I've already told you, we'll probably look at how to immediately get going with programming in Windows. So typically the JMP family, apart from the unconditional jump, which is just represented by JMP, uses processor flags to take decisions. So for example, whenever the carry flag is set, JC or jump on carry will go ahead and execute. Whatever address is given along with JC is where the next execution will happen. For example, whenever the 0 flag is set, JE or JZ, jump on 0, is going to be executed. And wherever the address has been mentioned after this, the next execution will start. So similarly, there are a lot of variations. We will look at some of them in the next two examples. So the first program which I am going to write is a simple one which will reverse a string, and it's called stringreverse.asm. So let's look at how this program functions. This part is pretty much common for all the code we've written till now. This is the sample string which we would like to reverse. We've created a 2-byte array, filled it with zeros, and called it temp string. Now let me first tell you what we plan to do. We plan to go from right to left, take every character and put it in the first byte of temp string. The second byte of temp string still remains a 0, and thus temp string becomes a single character string. Like this, we are going to print for each one of these characters from right to left. Now we'll do that using the jump instruction. So how do we do it? Well, first we go ahead and find the string length. This can be done using the szlen library called available with MASM32. We invoke that and give it the address of sample string. The result of this, which is the length of the string, is going to be stored in the EAX register. Now from this point on, we start the loop using our conditional jump. So we first define a label here called print next char, which is where we will jump to later on. Now then, after that, we go ahead and copy the first character, the rightmost character. Let's just scroll up, which is G, into the EBX register. Now notice that this is just 1 byte. However, the EBX register is 4 bytes in size. First we zero the EBX register by XORing it with itself. Then we actually move the first byte of the sample string from the right hand side, which is the character G, into the BL register, which is the lowermost register or the least significant bit, the least significant byte in the EBX register. Right? After that, we go ahead and move that character into temp string. So now temp string contains the character G and a 0, which is basically null. Then we go ahead and push EAX onto the stack. Now the reason for this is once we invoke a call like stdout, it will override the existing value of EAX, because of which we would like to first save EAX. So we push it on the stack, invoke stdout, which goes ahead and prints temp, and then jump till not equal to print next char. Now what JME does is till the time the previous operation did not result in a 0, it will go ahead and actually jump to this location. That is, this entire part will be executed over and over again till the value of EAX does not reach 0. Right? Now EAX contains the string length, so we move from right to left, decreasing the value of EAX so that we can access the next byte or the next character from right to left with every call. Right, so this loop runs pretty much till string length number of times of sample string. Hope this is clear. Download the code and try it out yourself. Let me just now go ahead and execute this. Already assembled and linked it just to save us some time. And if you notice, this is nothing but this is a simple string, everything written in reverse. Okay, so now let's look at the next program. In this we create a program which will print hello world 20 times and then hello security tube 10 times and then just exits. Right? Once again, very simple program. We call it multiprint.asm. Interesting names, huh? So let's open up multiprint.asm. So first we have a string which says hello world. Now hello security tube, well, I've converted that to we love security tube. I hope some of you watching this video at least love security tube. And now comes the actual code. So what we have is two very simple loops, loop 1 and loop 2, which are going to go ahead and do this. There's a simple catch here which we'll come to a little bit later. So the first thing we're going to do is move the value 20 into EAX and then invoke std out using the hello world string as input. And of course we go ahead and push and pop EAX before and after for the same reason which we mentioned in the previous demo, which is to preserve the value of EAX. Then we decrement EAX and then JNZ, which is jump on not 0 to loop 1. So this continues till the time the value of EAX does not drop to 0. Well, when that happens, we've already finished 20 iterations of this simple loop. Similarly, we do the same for the hello st string. Let's run this and see what happens. Can anybody spot a problem? Okay, let's run this. Let me go ahead and first assemble it. Then we'll go ahead and link it. And then let's run it. Now if you notice, we actually have an alternating hello world, we love security tube, hello world, we love security tube, I guess for 20 times, before we have we love security tube for 10 times. So why is this alternating? Any idea? Some of you may have already figured out the answer. Well, it's not really alternating. The mistake which we did was we did not null terminate these two strings, because of which actually hello world printed both of these one below the other. Right? So now that we've null terminated both of them, and we're wondering why, if hello st was not null terminated, why did it not crash? Well, probably in the data segment all values after this were already zeros. That's why it automatically got null terminated. However, in this case, after hello world, immediately we have the string we love security tube, which is why there was no null termination between both these strings. Hope you understood what we are doing. Let's now exit let me assemble this again, link it, and let's run it. And now we have the perfect output. Hello world 20 times, we love security tube 10 times, right? Awesome. So I guess that is all we have for this video demo. I would really encourage you to try programming these two simple demonstrations yourself. If you get stuck, use the code, right? Please leave your comments behind like always. Really encourages me to make more videos. Also makes me feel that people are actually watching the videos. So that's all. Have a great day. Bye bye.